Hey, we want to recover piecewise functions real quick. First thing is that piecewise functions are made up of more than one equation, and that's why they're called piecewise functions. Each equation has two parts. Okay, they're going to be the statement, which is the first part inside our piecewise function, and that is what f of x is equal to if the condition is met. Now the condition is the if part. Okay, it controls what part of the domain that this function or this expression is going to be defined on our graph. Now, let's start off with an easy example where f of x equals 3 if x is less than or equal to 0, and f of x equals x if x is greater than 0. So that's real easy to graph because f of x equals 3 is just a horizontal line. Okay, it's right here where x is 3. But I only want where x is less than or equal to 0. So I only want the negative part of my x-axis. So I'm going to draw a line like this, and there will be a point there where it is defined. So that's the first part of my function. The second part is where f of x equals x. So it's going to start here at the origin. But notice that it's x is greater than 0 and not equal to here. So that means that here at the origin we're actually going to have a hole, right? Because it's actually defined in the first part. It's going to be up here at 3. So the graph of f of x equals x is just the linear function looks like that. Okay? So as you can see, our function is actually in two pieces. All right? That's why it's called a piecewise function. It's in more than one part. All right? So that was pretty easy. We're going to try another example. That's going to be a little bit more complicated, right, but it's still not going to be that bad. Okay, we're going to start off with f of x equals x minus 1 if x is still less than or equal to 0, and the second part will be x squared if x is greater than 0. Okay? So let me clean up my axes a little bit. Okay? That's not too bad. Alright, so the first piece. Alright, f of x is x minus 1 if x is less than or equal to 0. So what I want to do is I want the linear function that has a y-intercept of -1 and has the same slope as the one we looked at before. So it's going to go like this because I want the side to the left of the origin. And again, in this part there is a dot there. It is defined where x is 0 in this piece. The second part is x squared if x is greater than 0. So again, we go back to our origin. And again, it's undefined here because it's defined in the first part of our piecewise function. Now x squared, of course, is a quadratic function. So we're going to have a parabola. So again, we have two pieces. All right, they're doing different things in different parts of our domain. Okay, the first half covers the left side of my axis, covers up to where x is 0, and the second half, of course, is to the right of the axis. Okay? Now, how about evaluating? What if we want to just plug in values? All right, I'm going to use the same examples, but I want to evaluate f of -2, f of 0, and f of 2. Okay? Now, what you want to do is whatever x is going to be, you find out where it is in the domain, what condition it meets. Here, x is going to be -2, so we look here, and it's going to fit this condition, where x is less than or equal to 0. That means we want to use this expression. So we're going to plug in -2 into this expression, where we have x minus 1. And -2 minus 1 is going to give us a value of -3. Next we look at f of 0. Again, it's going to fit the top expression because x can be equal to 0 in this condition. It cannot be here. So 0 is plugged in here. We get 0 minus 1, giving us a value of -1. Alright, the last one though, we're going to drop down to our second statement, okay, because it no longer meets this condition. So it meets this one, where x is greater than 0. So we're going to plug that in here. We're going to have 2 squared, which equals 4. Okay? So those are the basics. Alright, you want to check your domain and check whatever statement goes with it. Okay, if you are evaluating, you see where or which condition it meets and plug in accordingly. Alright, when you are graphing, you want to make sure you define what part of your domain it's going to be on, and start and stop there, and make sure your pole and your point are in the right place based on your operators here. Okay? Alright, well those are the basics. In the next video we'll talk about step functions and absolute value. Okay? See you.